Hey, what's going on? It's Mr. Dix here. I'm excited to show you an awesome problem that is from our 7th grade pre-algebra course using the Math in Focus curriculum. Take a second to read this to yourself and see if you know how to figure this out. So I'll read it to you, pause, and if you love math and you've never seen this before, let's see if you can just pull out a separate sheet of paper, and if you can, 1, solve the problem, or 2, can you figure out what's so hard about this? Let's face the math and respect the challenge and appreciate being confused, because this is awesome. I love it so much. I was talking to one of my fellow teachers, and they were saying, man, this is so hard. And I love doing hard stuff. That means it's a challenge. So let's read this problem and then figure it out together. 40% of the fish in a pond, this is a fish tank. It's easier for me to imagine maybe. 40% of the fish in a pond are goldfish and the rest are koi. The number of goldfish is G. So we don't know if it's 100 fish, 200, 450, whatever. We have G. The farmer then increases the number of koi by 10%. How many koi are there in the pond in terms of G? So when it says in terms of G, we know our answer is going to be an algebraic expression. And we know an advanced user would know that talking about in terms of G is comparing it's asking for the koi. How many koi are there in terms of relating it to the goldfish we started with? So, man, this is hard. Have you tried to solve it yet? Maybe you're here because you already tried and it's super hard. Do you know the answer? The answer is 1.65 G. So let's figure out why that's the case and what's so cool about this problem. Okay, so this is a percentage increase problem, and that's really hard to grasp when we're going up by a certain amount of percent. How does that affect the whole? And man, let me tell you what, it is really tricky to figure out. So I'm gonna draw a tank instead of a pond. You might like to draw a pond, but we have goldfish. And we have koi. So what do we know about them? Well, it's not necessarily 50-50 equal parts. Already, before we add anything in, it is 40% are goldfish. So I'm going to kind of chop this up like that. Yeah. And say that 40% of them are goldfish at the start, and the rest are koi. Do you already know that invisible calculation right there? You should be able to infer really quickly that if 40% of them are goldfish, then 60% are going to be koi. Okay. We're good so far? You got that far? Awesome. All right. The number of goldfish we are going to label G. Okay. So however many are in there at the beginning is G. Right now, this isn't in the problem, but let me just ask. How much koi is there in terms of G now? Is there equal? Would you say it's like 1 G here and 1 G there? If 40% is G, what would 60% be? It's more, right? So like an improper fraction, you could even compare it like, oh, it's like 60 to 40 G. It's not 40-40 G. It's not exactly split. It's 60-40, which we could even say that is 3 to 2 G. Or even 1.5 times as much koi as there is goldfish. Let's go back to the problem. The farmer then increases the number of koi by 10%. So how many koi are there now in terms of G? And we said, the answer is 1.65 G koi. Have you figured out why? If you have, comment below. What strategy did you use? How did you know it already? I would be impressed to hear. If you don't know why it is 1.65 G koi, let's keep going. And it probably has to do with this key sentence here. The farmer increases the number of koi by 10%. What's 10% of the koi? That would be this number right here. What is 10% of this? It's like a part of a part, right? You can divide this by 10. You could get a tenth of it. Let's answer this question. At the beginning, 10% of the koi is 6% related to the total. So 10% of the koi compared to the beginning fish is 6% of the total fish. And this farmer is going to increase the number of koi by 6%. Oh, my chair is blocking it a little bit. Okay, so let me write this a little smaller. Going to increase the amount of koi by 6%. You can see that? Okay, so how does that change? We were at 60%. Now we're going to add 6 more percent. So related to the beginning number of fish, that would mean it's 66. And I was struggling with this with Dr. Panazzo, and we were thinking like, well, we added 6% to the koi, then that should, if this is 66, then this is going to be 34% of the total. And Dr. Panazzo did something so brilliant. He used the strategy of substitution. Let's imagine that there are 100 total fish. So I'll write that. If there are 100 total fish to start, what does that mean G would be? If there are 100 total fish, 40% of them are goldfish. So that would be G is 40. And at the beginning, koi would be 60. Let's add 6 more koi. So we would have 66 koi. But does that change the number of goldfish? No, there are still 40 goldfish. So if I want to know how many koi are there now compared to the beginning number of koi, a goldfish, right now there are 66 koi, and compare that to the goldfish, there are still 40 goldfish. So we can get that with a calculator. Dun, dun, dun. Let's pull it up. 66 divided by 40. Bang! 1.65 G koi. Yeah, I guess this would be, this is not 1 times as much. This is not 2 times as much. This is 66 over 40 G. So we can simplify this to be, what's the greatest common factor, right? Divide it by 2. 33 over 20 G. And that is 1.65 G. So let's go back and talk about what we learned really quickly. And we're talking about increasing the number of koi. Remember, that's not adding 10% from 60 to be 70. It's 10% of the 60, which is 66%. And then we compare that to the original amount, that the 40% at the beginning doesn't necessarily change. It can just compare that base. So we had 66 over 40 G. Now, if you're interested on where the fractions were this whole time, check out this video I'm going to do over there or somewhere. And I'm just going to explain it really quick. But if you're good right now, and this is already complicated enough, we can just end it right here. But again, I just wanted to say, like, what a cool problem. Super tricky, little twists and turns. And you know what? Confusion is good as long as we can address it. So this is an awesome problem. Probably one of my favorite from the chapter review because I love doing hard stuff and I hope you do too. So thanks for watching. Take care.